All right, we are moving on to your second and final video lesson for the week. This also wraps up what we are working on with systems of equations. So there's one other kind of special case in addition to the one we looked at yesterday. So if you notice, these two are exactly like yesterday's notes. We'll just run through them again quickly. And then here is the second and last special case. So let's take a look at what happened yesterday. So yesterday we had a system of equations that crossed exactly one time. That's called having one unique solution. We could solve this algebraically using elimination or substitution, or we could graph it and find where it crosses. Either way, we know this from yesterday. Our solution was 0, 1. We could check it by inputting x equals 0 and y equals 1 into our original equations. Or we could just plot it on a graph and identify that intersecting point. Now, just to kind of review substitution yesterday, we did this one using substitution. What I'm going to do now is I'm going to do this one using elimination, just so we can try something different. In order to do that, we have one additional step, which I don't necessarily anticipate that you guys will have to do this year, but next year in algebra, this will be something you'll learn. But for now, I want you to bear with me. I'm going to do one little thing that I'm not expecting you to do. I'm just going to get this into a situation where elimination is easy. So I'm just subtracting that x to the other side. Okay, so that's the blue equation. Here, I'll rewrite the red one. So now this one's set up nicely for elimination. You don't have to know how to do that part. I just wanted to be able to show you elimination again. So right now I've got a 1 and a 1, right? So these have the same coefficient but opposite sign, which is exactly what we need for elimination. There's all sorts of things you'll learn next year about how to set this situation up for yourselves. So here is the variable that we plan to eliminate. Y plus y is 2y, and 1 plus 1 is 2. We would solve that for y by dividing both sides by 2. So we have y equals 1. We don't want to end here. We need both variables. So just pick which one you like the best and plug it in. I'm going to go with this one. So x plus 1 equals 1. We would just subtract the 1 from both sides, and we have x equals 0. So there is another algebraic way to solve this equation, or system of equations. Again, I don't expect you guys to be able to set up this elimination problem. If it's already set up for you, I'm happy if you can work from here down. I just wanted to show it to you again today as a quick little review. All right, so here is when we have one unique solution. You can solve algebraically, you can graph and identify where they cross. If you really felt like it, you could guess and check and plug x and y values in until it makes sense, but I don't recommend it. But that's just the first one. Okay. Now the second one we did yesterday also, and we noticed that it gave us a set of parallel lines where the slopes were exactly the same and they never ever cross. So this meant we had no solution because we're looking specifically for where these two lines cross each other, and they just don't. It doesn't happen. So yesterday, how did we solve this? Did we do substitution with that one yesterday? Yes, we did. So let's do elimination again. I'm going to set up elimination for you. So I'm just going to move this x to the other side. Okay, and then I'm going to rewrite the purple one. So let's say we were intentionally setting up elimination where we wanted these x's to cancel. So we had -1 and +1, and we're thinking, this is perfect. I love elimination. I'm going to cancel out those x's, and I'm going to solve the rest. But watch what happens. +y and a -y, those cancel too. We've got nothing left over here. 4 plus 1 is 5. So there's another algebraic way for us to see that this has no solution. We ended with a false statement, which means there's no solution. We could have done this with a graph too. You just plot them, see that they're parallel, or if you would solve them each for y, see that they have the exact same slope. Either way, there's lots and lots of ways to identify that this system of equations has no solution. Easiest way, plug those equations right into Desmos, notice that they're parallel, and that's all you would have to do. I don't recommend that you jump right to that option. I want you to try it algebraically first, but there is definitely nothing wrong with using Desmos to check your work at any time. All right, these two we had already done yesterday. Here is the third and final problem. So in this problem, we only seem to have one line. I tried to color code it so it had red and yellow and your answer is orange, because watch what happens. Let's say I regraphed these. Y equals negative x plus 2. This has a y-intercept at positive 2. Okay, that's right here. And it has a slope of negative 1, so down 1 over 1. Okay, so there's the red line. Now let's look at the yellow line. I'm going to solve that for y first. So if I subtract that x from both sides, I'm going to have negative x plus 2. Okay, so this has a slope of negative 1 and a y-intercept of 2. Let's start with the y-intercept of 2. Same y-intercept as the first one. Okay, we've got a slope of negative 1, down 1 over 1. Same slope as the red line, which means this was the red line and this is the yellow line. That's why I made it orange. So these two lines are the exact same line. Because they're the same line, when I physically draw in that second line, I'm always intersecting the first line. So all the way to positive infinity and all the way to negative infinity, these lines are always going to be crossing, which means there is an infinite number of solutions because it just keeps going. Okay, so these are just going to keep crossing forever all the way. A couple ways to identify that. We could solve this by substitution. We could graph, we could solve by elimination, we could plot it in Desmos, it doesn't matter. We solved it by graphing here. Let's say we wanted to solve that by substitution. Let's pretend I hadn't solved this one for y, and let's do substitution. So if y equals all of this, I'm just going to replace the y in the second equation. Okay, so this is going to be x plus what used to be a y equals 2. In place of that y, I'm going to put negative x plus 2. So now I just need to solve. There's nothing to distribute, so I'm going to combine some like terms. I have positive x plus a negative x. Those are going to cancel, and we're left with 2 equals 2. So our variables all cancel just like yesterday, but this time we end with a true statement, which means no matter what x and y were, they're going to cancel out and it's always going to work. So when all the variables cancel, you get a true statement because you're solving algebraically. That means there was an infinite number of solutions. You don't have to do all these methods. I want to make sure that's really clear. You can solve algebraically, you can graph. You don't have to do them both. So don't make too much work for yourself. I just wanted to show you all the different variations of it today so you weren't confused. So what we're going to do is on the next page, there's 4 problems. We're going to do 2 of those together, and you're going to do 2 of them on your own. Okay, so let's take a look. Choose what method makes the most sense for each problem. So this one, I think substitution makes the most sense. I've got y alone in both. Graphing would actually be pretty easy for this one too. But let's pretend we weren't graphing. Let's do this algebraically. So I'm going to take x minus 1, and I'm just going to replace the y with that, which means I'm really just setting these two things equal to each other. So x minus 1 equals x plus 2. Okay, let's move this x to the other side. So we're going to subtract it from both sides. We intentionally canceled here. This we didn't intend, but it happened. And we're left with negative 1 equals 2. So all my variables are gone, and I have a false statement. That means no matter what we plugged in for x and y, it was never going to work. It has no solution. One thing I noticed right away before we even started that problem, they both were solved for y, which means they're in slope-intercept form. I noticed their slopes were exactly the same. They both have a slope of 1, and they have different intercepts, which means they're not the same line, but because they have the same slope, they were parallel. So I knew there was going to be no solution right from the start. All right, second one. This one is set up pretty nicely for substitution also. So I'm gonna go ahead and do substitution again. Okay, y equals x plus 3. So the x plus 3, I'm just gonna replace the y with that in the second equation. So this one, I'm gonna rewrite it as x minus, this used to be a y, equals negative 3. In place of the y, I'm gonna put that x plus 3. I do need to distribute, so I'm gonna take that negative 1 and multiply it through the parentheses. So I've got x minus 3 equals negative 3. I'm gonna combine some like terms and notice what happens with these variables. I have positive x and a negative x. Those cancel. And I'm left with negative 3 equals negative 3. So there's no variables. All the variables canceled out, and I'm left with a true statement, which means whatever I plugged in for x and y was always going to work no matter what. So this has the infinite number of solutions. I-N-F-I-N-I-T-E, almost spelled that wrong. Infinite number of solutions. One way I could have told you that in the beginning, if we had solved this one for y, we would notice they were literally the exact same line. They both were y equals x plus 3. Let's take a look at those on Desmos, and then you guys will be doing these bottom two together. But first I want you to be able to see what this looks like in Desmos. Okay, so let me go ahead and input these for you. Number one we had was y equals x minus 1. And our second equation was y equals x plus 2. Okay, there's those parallel lines. So they both have the same slope, but one of them has an intercept at negative 1, the other has an intercept of 2. So we had written that there was no solution, and we can verify that using this graph. Okay, let's look at the second one. So we had y equals x plus 3, and our second line was x minus y equals negative 3. Notice we only have one line here. So we had a blue line and a green line, and now they're overlapping, which means they're always crossing. So there's an infinite number of solutions because they're always on top of each other. Okay, so if I get rid of one, doesn't even look like anything changed. All right, there's 2 problems left. You guys are going to work on these 2 problems on your own, and you can hit play when you're ready for their solutions.